see my screen, and I can see my title slide. So I'm going to be talking about, well, the reason it's called the Pebble Spotter's Guide is because I've just written a book for the National Trust, and this is the book, and it's available online. And I think Waterstones, I've just popped into Nottingham recently, and they're going to stock it. And the Token House, in fact, actually got a nice display in the window in Nottingham, and that's right in the middle. Let me just explain. Oh, here we go. Here's a pebble. Look, can you see? This is one of my favorite beaches. In fact, the reason I went to this beach is back in the summer last year, when I was sort of midway through writing the book, was basically to pick up a few more pebbles for the book, because I needed 40 different pebbles. And I found it quite hard to find 40 different rock types. And I'll explain in a bit more detail. But I'll just give you an idea who I am. As Peter said, I work for the British Geological Survey. I'm an industrial minerals geologist. I've been at the BGS since 1989, so I've been there quite a long time. It's not unusual for the BGS. There's a lot of people that tend to stay in this organisation. It's a good place to work. I'm a chartered geologist, so that's the sort of like professional status. I've been very lucky in my career. I've done a lot of work internationally. I worked in Afghanistan, going back about, when did I do that? 2005 to 2007. So about 10 trips to Afghanistan. And that was a sort of typical, what we call institutional strengthening project, basically training and helping the Afghan Geological Survey get back on their feet. And I've done a lot of work in Africa, places like Zambia and Kenya, and currently doing quite a bit of work in the Middle East, in UAE, and places like Saudi Arabia, and also in the past, a lot of very hot and sweaty work in Thailand, in the sort of jungles, the rubber plantations in southern Thailand, looking at limestone. And the sort of things I do, where it says here resource assessment, and what that means is my job is to work out what all of these things are good for. So, for example, andalusite is a refractory mineral which might be used in kilns, and clays for making brick. Well, is your clay deposit any good for making bricks? And so on. And I'm the sort of person that will go out with a mapping geologist, find the resource, take samples, go back to the laboratory, do some test work, write a report, and then make my recommendations, yes or no, this stuff is good for this particular application. So that's what an industrial minerals geologist really does. As you can see here at the minute, I've sort of branched out into small-scale gold mining, research that is, not actual mining, and that's in Kenya. There's a lot of issues with gold mining, because mercury is something that a lot of miners use for recovering gold, and mercury is poisonous. And one of the things they do is they actually burn away the mercury from the gold concentrate, and of course, mercury vapor is then breathed in, absorbed into the atmosphere, it falls down into the rivers and the fish, and they eat the fish, etc. So it's pretty nasty stuff. So we're looking at technologies for removing mercury from the gold processing carried out by small-scale miners. And another thing I'm looking at is graphite. Now, you may know about graphite. It's a very sort of black mineral. It's a very soft mineral. It's actually used in pencils. So a pencil is a mixture of graphite and clay, which makes the pencil lead. But it's also an important aspect of rechargeable batteries. So a lot of renewable rechargeable technology uses graphite, as well as other minerals like lithium, etc. in this sort of, so it's what we call a critical mineral. So there's a lot of interest in graphite around the world, and most of graphite production with a lot of critical minerals is currently from China. And there's a big concern about what we call security of supply of these resources, because if the Chinese decide to stop supplying it, industries around the world would struggle to produce the materials, the batteries, etc. So here we go. So let's talk about pebbles. So why am I showing you a picture of me as a small boy when I was 5? This is pretty much when I started collecting pebbles. I mean, as a kid, I remember being on the beach. I lived in the West Country. I had no idea what they were. They were just nice to hold. And it's the law. If you're a small boy, you have to have at least one pebble in your pocket. And I was no different. I was just fascinated. From Somerset to Cornwall, and back in those days, we're talking the sort of like back in the 60s, late 60s. It's still quite a long way, even now. but that was our main family holiday. So over 50 years ago, and if we whiz forward sort of like 50 years, my sort of renewed interest in pebbles came about because I was contacted by a lady called Paula Kokoza. Now, Paula is a journalist for The Guardian, and she spent a summer with her kids, and they found a leaflet in the little holiday rental that they were staying in. And this little leaflet told them about the local geology and the pebbles on the beach. So much to her husband's bemusement, she spent 2 weeks with the kids just doing nothing but looking for pebbles and puzzling out what they were. So this sort of fascination made her realize that there may be a story in this. So she got in touch with the British Geological Survey. And at the time, I was working in the communications team. And being a geologist, probably the only geologist in the communications team, I thought, well, actually, I could do this. I could do this interview. I don't need to find another scientist. I'm a scientist. So I met Paula with a Guardian photographer in Cromer. And this is us on the beach in Cromer. It was December, end of 2016, and it's pretty cold and wet. So it didn't look too bad in that image. And we spent a couple of hours looking at pebbles, chatting about different rock types that we find on the beach. And she went away and she wrote an article. And that article is still online. If you Google No Stone Unturned, my search for the Pebble Hunter's Holy Grail, it was actually published in a supplement to The Guardian called Wild. And it was very much the sort of outdoors sort of things that activities, and pebble hunting was one of them. And like I say here, and pebble hunting really is what geologists do on holiday. It's a bit of a busman's holiday, but you can't take the geology out of a geologist. If you go on holiday, inevitably you'll be on a beach and there'll be cliffs, or you'll visit a local town and there'll be building stones. And I'm the person who is up against the stone wall, stroking the stone, trying to work out what it's made of. So I am the family rock stroker, as that's my nickname in the family, slightly embarrassingly for my kids, I think. But there you go. As a geologist, that's just in your DNA. And I know that when I retire, I'll still be a geologist, and I'll still be stroking rocks and collecting pebbles. So here we go. Here's the book. I restarted collecting pebbles after that interview with Paula, thinking, well, I might do something because I'm in the comms team. I might do some web content, etc. And then out of the blue, I mean, like I say here, I know what they are this time. I've got loads of them. And just out of the blue in 2019, I was contacted to write a book. There's a company called Pavilion. Now, Pavilion Books Group do most of the book publications for the National Trust. And I think it was them that came up with the idea for a book on pebble spotting, they called it. So it took a while for to get the sort of all the sort of legal stuff together, because I've done this as a project through BGS. Now, as I'm public sector, you might be thinking, oh, this is a nice job, you know, I'm getting tons of royalties from this thing. As I'm a public sector scientist, contractually, I can't do work of a similar nature to that I could do for BGS. So the only way I could write this book was as a BGS project, which means that all of the royalties for the book go to the BGS. I get the kudos of the book, and I get to speak to lovely people like you and tell them about what I've done. And I'm proud of myself, and my family are proud of me for writing it, but I'm not actually earning anything from it, which is, you know, fair enough. I never thought I would write a book. So actually, I was really quite happy to do it. And because it took so long to sort of like get all the stuff organized, by the time it came to the first lockdown in 2020, it was coincided with my main writing period. So I actually, in the middle of March, just packed up some boxes of pebbles. I literally took rocks home with me. And in the back bedroom at home, I spread out all the pebbles, literally 200 pebbles. And I had to select 40 pebbles for the book. And that's what I did. And then it was published, and it was published this June, so the 10th of June. So it's only been out a short while, although it's been on online, Amazon, etc., for a little while, and it's done okay. If you look online, you'll see it's the #1 best-selling book on historical geology. Bit of a niche sort of like category, I think, but it's doing okay. And the last I'd heard, it's sold at least 2,000 copies, so it's done okay. Okay, let's talk about pebbles themselves. So what is a pebble? I mean, it's interesting, isn't it? Because, you know, it's obvious a pebble is a pebble. So what is my definition? It's not necessarily a technical definition. And I think this is the definition that I've gone with, that I think neatly describes what a pebble is. A smooth rock that fits neatly into the palm of your hand. Now, this means that obviously if you've got a big hand or a small hand, the size of the pebble can vary. And I think, well, that's just natural. There's the natural variation of geology. We can get pebbles of all different types. And they can be made from lots of different types of rock, such as granite, limestone, sandstone, invariably hard rocks, things that have survived the sort of like natural processes of erosion and weathering to get to the point where it sits on the beach as a hard lump of rock. But not all pebbles are rocks. Some of them may be artificial, such as glass, concrete. So if glass, for example, if you've ever been up to see them up in the northeast, there's lots of glass on the beach, a lot of waste glass that's been turned into glass pebbles. Concrete, brick, tarmac, a lot of this stuff, this is artificial material, has worked its way onto the beach from sea defences, maybe from houses and walls that have fallen into the sea because of coastal erosion. And they've gone through the same process as rocks on the beach. They've rounded it into pebbles. So where can you find them? Well, hopefully, now this picture here, this is Whitby. That's another favourite location for pebble hunting. Fantastic place. I love Whitby. And they can start off, life as rocks that may occur in mountains, and then through the processes of weathering and erosion, those rocks are broken down, and then they're carried from the mountains and hills down to the sea in rivers and streams. So you'll find them in rivers. Along the way, that river may pass through a lake. So that often that lake will then capture a lot of that material, so that those rocks have been transported away from where they naturally occur. So you may then find lacustrine lakes, beaches. Then obviously, when the river hits the coast, what happens is that big rush of water hits the sea and decelerates. So basically, the water velocity slows right down, and it dumps a lot of the heavy material at the coast. That's why we have beaches in a lot of cases, and that's where a lot of the pebbles may come from, because that sediment load has been dumped at the coast, and then maybe the silt and clay get washed out to sea. But you also find pebbles on land, and you can find, for example, Nottingham's quite classic. We go up to Blidworth Woods, we're underlain by a pebbly sandstone, and those pebbles will then work their way out of the rock, and you'll find those pebbles in the soil. So if you go to Blidworth Woods and you're walking around, you'll see pebbles of quartzite and sandstone and other rocks actually just in the sandy path, because the sandstone is broken right down to sand, but the pebble is resistant. So you'll often find them. So they're not always at the coast on beaches. So how are they made? So as I said before, we get the process of weathering, erosion, all sorts of different things. Ice, rain, heat have their role in that. Wash down and then rounding, basically that transportation process. It's a sort of self-abrasion process where the pebbles are knocking into each other, and that basically then smooths them and rounds them. The further you get from the source, the rounder they become. Because if you imagine that when they're initially broken from the mountain, they'll be quite angular and sharp edges. But the further they go from the source, the rounder they become. So that's one way of sort of gauging how far this has come. How round are they? And some rock types become round, others might stay flat. And this process continues on the beach. Now, this is a question I get asked occasionally. Why do some beaches have pebbles and not others? Interesting question. I know I wrote it. And the reason for this is that because often you may have local cliffs, and that may be an immediate source of material for the beach. So you'll get pebbles from those cliffs. Not all beaches have got cliffs, so you may just have sand. And this particular case, I think this was Flamborough, and you can see this chalk. And chalk is a very soft material. Chalk does not survive very long on a beach because the water washing backwards and forwards, and it gets broken down very quickly. So if you find chalk on a beach, it's because it hasn't come very far. You know it's only come from fairly locally. And the geology, like I said, some places have hard rocks and others don't. So, you know, this is a soft rock. Other places may have granites, and that's really tough stuff. So that will transport a long way. So let me just have a sip of water. Folks, don't worry if you've got any questions, just butt in, I'm quite happy. So let's have I'll think about, you know, what do I do when I go out to look for pebbles? Now, here we go. Here's me holding quite a nice pebble. This is actually a rock known as a rhomporphyry. And this is a lava. So the darker matrix, which is the sort of the darker grayer bit. And then we have these sort of almost diamond shaped crystals of feldspar, which have grown within the magma. So what we have is a mixture of very fine grained lava with crystals. So when this lava has been erupted, the crystals of feldspar are sort of entrained within the lava. So what's happened is when it's cooled down as a rock, the lava has cooled very quickly, which then stayed very fine grained, which is the dark gray stuff. But the crystals of feldspar had already grown in the magma chamber. So that's why you get this thing. It's a porphyry. If you find a rock like this with lots of crystals, it's called a porphyry. But if it's diamond-shaped crystals, and you find a lot of this rhomporphyry on the East Coast, and I'll talk about that in a bit more because I've got a whole series of pebbles to show you. And one thing I would say is there are local bylaws which govern what you can take away from a beach. You may not realize this, and I'll go into that in a bit more detail. It's a hard thing to check. I've realized when I wrote that sentence thinking, well, I've tried to check this, and it's very hard to find out. So I'll talk about that in a bit more. I've got a whole slide on that one. But one thing I recommend is that, I mean, I find myself doing this, walking up and down the beach, looking for pebbles, head down, just scanning around, trying to look for pebbles. And actually, I've realized the best way to do this is take a bit more of a thorough approach and just find a spot like this group of pebbles here under my hand here where my notebook is, just sit down and look at every single pebble around you. It's a bit time consuming, but actually you'll be surprised if you pick every pebble up and turn it over what you may discover, because you may miss the fact that sitting underneath that pebble, I know there's a vein, or there's a geode, or there's even a fossil, an ammonite. The other thing I would say is that what happens on the beach, especially a pebbly beach, it's a bit like your box of cornflakes. If you've got, you know, basically, if you've got cereal, which has got raisins in it, okay, and you've got big flakes, okay, what happens is all the big flakes go to the top. It's called segregation. And this is what happens on a beach. All the big pebbles, it's weird, it's a bit counterintuitive, but actually what happens is the smaller things slip between the spaces between the bigger things. So so what happens is different types of pebbles might sit underneath that top layer. So if you remove the top layer, you suddenly might then find some really interesting things. You might find a little pyritized ammonite, which is a little tiny ammonite made of iron pyrites. Or you might find a little piece of carnelian, which is a really lovely sort of like deep red translucent silica mineral, which is fantastic. These tend to be quite small. It's worth spending the time just to sit down. You'll miss these things if you just walk up and down the beach. And I've been told this is very much mindfulness with pebbles, and I think you're right. And what can be worse than sitting on the beach anyway and just drilling with some pebbles? It seems like a good idea. I would recommend this, a camera or a smartphone. If you've got a smartphone, if you take a photo, you'll find that actually there's information recorded with that image, geographical information, and it uses the GPS on your phone. And you can then use that information. You can actually geolocate that photo. And there are apps that can help you geolocate. So you actually use the image and put it on a map. So this is a really neat way of recording the location of what you found. It's also a nice way of recording what you've got as well. if you don't want to take the pebbles, I mean, I don't keep all the pebbles I pick up. I only take one or two. But it's a really neat way of doing this. And you can see I've got in this image the yellow and black device, that's a GPS, and I've got a notebook. So I'm still a little bit old school. Even though I use my GPS to record the GPS coordinates, I still write down the coordinates in my notebook just in case, just in case the battery goes or something on the device. And then some tips on recording pebbles or collecting pebbles. One thing I would recommend, and this is a hand lens. I've got my hand lens here somewhere. Here we go. Any good geologist is not without his hand lens, and I've always got a hand lens within short vicinity. And if you're looking for a hand lens, they're very cheap on the internet. Times 10 or times 20 is the usual magnification, and I recommend getting one of these because it really does reveal a lot more detail. And if you're using a hand lens, top tip, rather than using it like a magnifying glass like this, what I suggest is that you bring your magnifying glass right up to your eye and then bring the pebble up to it. That way, you'll see a lot more detail. It's quite hard to see what's going on like this with a hand lens. A bit easier with a magnifying glass. Well, magnifying glass would work, obviously, but this is easier for when you're out in the field or on the beach. So you can see a lot more detail, and immediately I can see all sorts of crystals of quartz and feldspar and mica in this rock here. So that's something that I call it the ooh factor, because I do science week at BGS, and we have kids in from local schools, and I teach them how to use a hand lens. And as soon as they get their eye in, they go, ooh, they can see what's going on. Fantastic. Reference books. I've got a few reference books to recommend, and I still use reference books. You know, I don't know everything. I don't know all the rocks and minerals. I always like to take a book with me. If you're going to collect, and I always take a few bags with me, and maybe a cloth bag as well, something a bit stronger. And what I tend to do is I individually wrap each pebble, because obviously if you've got two pebbles together, they're going to do what they naturally do. They're going to rub together, and then what happens is it gets really dusty. You get lots of bits of material coming off the pebbles. So just purely to stop them from being damaged, because if you put them in one bag, it only takes 2 or 3 pebbles together in the bag, and within half an hour, it's just a dusty mess. So, and you might individually wrap some, because you might have some really nice ones. You might have a nice fossil, and it may not be so nice if you don't wrap it up. So I recommend that. And the other thing as well is that I usually write a label, you know, on my bag. But the other thing I tend to do is slip a paper inside the bag, because yes, this is indelible marker on here, but that can rub off. So if you put a slip of paper inside as well, that's just a top tip from me as a scientist, really. That has saved my bacon on sampling trips so many times, when I've just put a slip of paper inside just with the reference number for that sample. I know where it comes from. Otherwise, what you've got is a bag of rocks, and if you don't know where they're from, that basically means they're useless to you. You can't use them in your work. Hammers. Now, you would think a geologist would be all about hammers, and this is my hammer. This is an Estwing. This is a classic geological hammer. This has seen plenty of action. This has got a small one. I prefer the small ones because the big ones are heavy, basically, and I can slip this one in my rucksack and it doesn't really get in the way. I would caution the use of, the use of hammers. I'm not saying don't use them. I'll just say be very careful. Multiple times have I hit myself on the thumb, or chips of rock have smacked me in the face, and you have to be really careful. And yes, if you take a hammer to a piece of rock, you know, say for example, you go down to the southwest, down to a place like Lyme Regis or Charmouth, you can get nice concretions that if you break open, you'll reveal a fantastic ammonite in the middle. And this is, you know, I see this on Twitter all the time, fantastic ammonites, pyritized ammonites. And you may see geodes as well. You may get calcite, quartz crystals, and, you know, they're fantastic. But if you're going to do this, please wear eye protection, consider gloves, and also look out for anyone around you. Because the last thing you want to do is hit something and then a piece of rock fly off and hit a kid or a passerby. That's, yeah, just be cautious of that. And the other thing I would say as well is that we generally don't hammer into cliffs, because cliffs, certainly at the beach, are often unstable. If you hammer into a cliff, you may precipitate rockfall, because that vibration, that might just be enough for a big lump of rock 10 feet up to come crashing down. And it does, and rockfalls do happen. Cliffs are vertical, they're often to be avoided. And if you look at the height of a beach, if you look at the height of a cliff on a beach, our engineering geologist said, well, if you look at the height of the beach and to say, how far away should I be? The height of the beach, the height of the cliff is the distance you should be away from the cliff. So if you did that, you'd basically be in the sea in most cases. So they're saying you can't guarantee safety up against, in certain places. You hear of stories, rare stories, but fatalities have happened in the UK in beaches in the last 5 years, where sudden rockfall. If it's been raining, what happens is the rock gets saturated, and that makes the rocks really heavy, and the fractures then open up, and then you get rockfall from the cliff. So I'd be very careful about that. A few more things on safety. I've mentioned rockfalls. If there are warning signs, just read them, and don't be caught out by the tide. It's too easy. In some places, the tide. I mean, I've just come back for about a couple of weeks ago. We're at Holcombe in Norfolk, and Holcombe Beach is incredibly flat, and the tide races in really quickly. It's a huge beach, but it's very, very flat. So the tide can come in sometimes quicker than you can run. So you have to watch out. Also, some beaches are very steep as well, and you might just get caught off and knocked over because of large waves. Again, watch out for hammering into cliffs. And I mentioned the thing about wave protection. So this is an interesting one. Is it legal to collect pebbles from the beach? Now, there's been quite a few scare stories about it's illegal and you'll get fined £2,000 from collecting pebbles from the beach. And yes, in some cases. Now, I looked into this, and the law that covers pebble collecting is the 1949 Coastal Protection Act, which gives there is a provision for local authorities to create a local bylaw prohibiting the excavation of materials, including pebbles, from specific beaches and or coastlines. However, this only comes into effect when the local authority puts in an application to the Minister of State. So they have to actually create a bylaw. It's not a blanket provision for all of the coastline of the UK. It is well, I should say Great Britain. It's not a blanket. So if you read the articles that say, oh, it's illegal to collect pebbles, it's in certain places. And there are certain famous beaches in the UK, Budleigh Salterton, Chesil Beach, Crackington Haven. Crackington Haven was a famous example a few years ago, where in 2018, someone was forced by the local authority to drive several hundred miles back to the beach. And he had actually made away with quite a few big bags full of rocks, of pebbles though. So he was taking the mickey a little bit. I would say that, you know, in most places there are signs. If there's an act in place, there'll be a sign. So just look out for the signs. And if there's no signs, I think it's reasonable to assume that you're okay to go ahead and collect a few. And I would only collect, maybe on most beaches, only collecting no less than half a dozen at the tops. And typically I'd only be coming away with a few, or 2 or 3 maybe. So, I mean, I don't have the numbers, but I think it's most beaches in the UK are okay to collect pebbles from. It's just one of those funny things that it's the typical media thing. You know, what happens is a journalist will then Google, he'll find that story about Crackington Haven and just say it's illegal, but it's not the case. And here we go. This is some of the examples of signs. The one for Crackington Haven, actually, the locals complained about the sign. So they actually said, this sign's awful. So they actually replaced the sign with one in black and grey, because they said this one just looks terrible. But you'll see these things. And the top right one, I think that's the one for Chesil. And this one down right is down in Pembrokeshire. I would have thought it would have been a bit more official than this one, because this one looks like it was just done locally. I did say I would recommend a few books for Pebble collecting, and Pebbles on the Beach. This is the classic book by Clarence Ellis. This was published originally in 1953 and was republished in 2018. So it's got a foreword by Robert Macfarlane, if you know, he's a relatively famous writer. And this is a good book. It is written in the 1950s style of writing, but it's a go-to really for pebbles, how pebbles are formed, the geology, what beaches to find them on. I wouldn't rely on it for trying to help you work out what pebbles are, though. I mean, in this particular edition, the only images are really on the cover. This other book on the right is a really lovely book, the Book of Pebbles, but it's a bit more of a sort of evocative storytelling about pebbles. I read it in one sitting in a couple of hours. It was such a nice book to read. If you're a bit more interested in the geology of working out what the rocks and minerals are, I recommend these two books. The one on the left is the classic Dorling Kindersley, amazing clear images that they managed to create for the Dorling Kindersley books. This is probably by far and away the best book on rocks and minerals. It's quite a big book, but they do actually, there's a smaller sort of concise version of this book by the same author. And the one on the right, The Rocks of the World, a complete illustrated guide. Again, it's very lots of images, but this is much more about the classification and the explanation of the different types of rocks and how they relate to each other. And that, again, these are the two books. These are the two books that I probably used the most for when I was putting my book together. This is free. If you're interested in geology, I would recommend, if you've got a smartphone, to download iGeology. It's an app. It's available for Android, for your Apple and Android phones. iGeology is essentially like having all of the geological maps of the BGS in your pocket. And it uses the GPS on your phone, and you click on it and it will zoom to where you are. So you can see what I've done here. I've basically found your normal meeting place in Wedge Bridford and looked at the geology. So I then clicked on the geology, and the one on the left, it's the bedrock geology. So the one at the bottom. The one on the right is the superficial geology, which is the Holme Pierpoint sand and gravel member. And you can see on the left here, you can create an account. You can select between superficial, which is essentially the top layer of geology, the bedrock, which is the rocks underneath, or the combination of both. So that's a free thing. What I thought I'd do is run through a few pebbles, just to show you some of the things that are actually found in the book, and just to give you a little bit more. And I talked about this one earlier. This is Ron Porphyry. And what I didn't tell you is that the really amazing thing about this rock is that it's not from the UK. It's actually from Oslo. And what's happened is that during the Ice Age, this rock has been picked up by glaciers, which have been sailed across the North Sea and then deposited this on the East Coast. And this has come a long way. I've been to the quarry just outside Oslo where this rock comes from. It's something that you find in very few places, very distinctive. And this actually made it into the Guardian article as well, this pebble. This next one, this is a limestone. And all these round dots are actually coral. This is a colonial coral. So I found this one, I think this is on the Yorkshire coast. I think it was Mapleton or Caton Bay, something like that. The Yorkshire coast, the East Coast, is amazing for different rock types because a lot of them come from glacial material from across the UK. This is a really nice one. This next one is gneiss, and that's how you pronounce this, G-N-E-I-S-S. It's in fact, the Lewisian gneiss in northwest Scotland is some of the oldest geology in the UK. It's over 1 billion years old. It's absolutely amazing. And this is a metamorphic rock. And this started life, this particular one, I suspect, started life as a sandstone, which has been changed by heat and pressure, and the minerals have crystallized out. Here we go. This is another one. This is a basalt. And all of these white blobs here are what we call amygdales. And lava has gas in it because it's very volatile. When it's erupted, there's a lot of gas bubbles. And sometimes those bubbles of gas don't escape from the rock. They get frozen into the rock as little round holes. and those round holes then get filled in with calcite or other minerals. So we get this amygdaloidal basalts. Here we go, it's a sandstone, and this is a nice one. This is easy to recognize. Sandstone has a very rough texture. Often, sometimes it doesn't, sometimes it's smooth, but this is obviously, it could easily come from a beach or a lake or a river. It's laid down and it's a sedimentary rock that's been compressed into rock. This is another one of my favorites. This is something called phyllite. It's a very strange rock because it has like a wavy surface. It has lots of these little dots. And what's happened is this started life as mud, which then get changed by heat and pressure into a shale and then into a slate. And then it's been pressed even further. It's continued the metamorphism, and you get this crenulated cleavage, which is the sort of like undulating surface. And new minerals start to grow in the rock because of the metamorphism. And these are called porphyroblasts. So there you get little minerals of andalusite, cordierite in the rock. This one's from Arran, from Scotland. It's another lava, a little bit like the Ron porphyry, but this one's called a quartz porphyry. You can see the sort of like buff-colored lava, the white feldspar, and then the grey sort of roundish looking quartz. This is lovely. This is one of my favorite rocks. Fantastic little quartz phenocrysts. May not be obvious what this one is, but this is a flint pebble, and it's actually a flint pebble which is formed around a sea urchin. So this is actually a fossil of, it's called an echinoid, but an echinoid is essentially a sea urchin. And the weird thing about this is that of all the flint that we get in the chalk, and if you go to the south and the east coast, you get loads of flint. They think that the silica that makes the flint comes from the spines of sea urchins. So what's happened here is that the spines from this sea urchin, the silica has dissolved and mobilized and then replaced the fossil. So it's sort of colonized itself. This one's a schist, and a schist is basically a rock full of mica. And you can't really tell, I've got a piece here, and you can see if I hold it like this, how shiny this is. And what's happened is, a little bit like the phyllite, but this has kept going. The metamorphosis has recrystallized the minerals, and all the mica has grown out of the clay. And what happens is it grows in layers. So it's actually, that's why it becomes so sort of platy and shiny looking. This one is a gabbro, a little bit equivalent to a granite, but it's a different composition. So you get very coarse crystals, and this is crystallized deep underground in a magma chamber. And you might be familiar with this. This is chalk. Now, it's not the same as the stuff that we use on chalkboards. Chalk that's made of gypsum, which is softer. This is calcium carbonate, and the fascinating thing about chalk is it's made of billions of tiny microfossils. It's full of fossils. It's almost entirely fossil. So little things called coccoliths. It's an amazing rock. It's a type of limestone. And here's a granite, and one of my favorite rocks. And we've got lovely coarse crystals of pink feldspar, grey quartz, and white feldspar with black flecks of mica. And you'll be relieved to know we're coming towards the end of my talk. I recommend my book, obviously. I also recommend, if you're interested, joining the Facebook group. If you look for Pebble Spotters on Facebook, you can join the Pebble Spotters group. And if you do, use the hashtag Pebble Spotters, and hopefully then I can get either myself or others to help identify pebbles that you may have found. And thank you very much for your attention. And I look forward to any questions that you might have. Peter, I hope I didn't talk too much. I did warn you I could talk for England on this.
No, you've done really well. So questions, please. I'll kick off if I may. You showed us quite a few pebbles where there were lots of different materials in the pebble.
Yeah.
But they seem to still be pebbles. So I'm thinking, how did that happen? Are the materials just fortuitously the same hardness and get worn away the same, or what's happening there?
I think the natural process of weathering and erosion has selected the hard stuff to be pebbles. You're absolutely right. So there are certain rocks, like the chalk, for example. I mean, this has come very close to where it came from a cliff. So it wouldn't survive long against other things like, you know, the granite, for example. These two together on the beach, this will survive, this will disappear very rapidly. We might be talking days, weeks. This will still be around, rounding off nicely, and it will be there. So there is a sort of, you're right, there's a sort of process. I mean, pebbles are made of rocks, you know, naturally, you know, like I mentioned, we've got all the artificial things that can make pebbles, but they are naturally occurring geological materials. They are rocks, basically. We just call them pebbles because it's a sort of just a catch-all term, I suppose.
Right, but their shape is a consequence of the way that they've lived their life, if you like, being sort of tumbled down rivers and washed away and that sort of thing.
It's interesting because often a lot of pebbles aren't round; they're sort of flattish.
Yeah.
This one, it's sort of round that way, but flattish this way, and this is partly a function of the structure of the minerals in there. They might be slightly layered, and that lends itself to the way the rock is broken. So
right.
it was naturally flatter to start with. And so other rocks might be a bit fatter, because they're a bit more uniform. So they break in more sort of granular lumps. They're a bit more blocky. But even granite can be still flattish. So it's interesting how that happens. And I think once it starts getting worn in a particular direction, I think it just gets sort of, you know, that process continues. So it's quite an interesting phenomenon, you know, but I think Clarence Ellis talks about how pebbles are formed and this natural tendency for this to be slightly flattish, which is weird, but it's quite nice, you know. I quite like that because it's a nice, fits in your hand quite nicely.
yeah, it's good. It's good for bouncing on water as well.
Yeah, exactly. Yeah.
But the other thing I wanted to ask was, you mentioned that pebble that came from Norway.
Yeah, the porphyry.
And I mean, my first question is, how do you know? I mean, I know you said that it matches the quarry that you visited and that, but
well, it's because it's only found in 3 places in the world, right. And the only place in Europe this rock comes from is just outside Norway. And there's you get plenty of other rocks which are called porphyries like this, but they don't have the distinctive angular diamond-shaped crystals. That's the giveaway. That's the giveaway. I was just thinking if I've got a piece here. I can't see a piece here actually. But that's the giveaway. It's that characteristic. It's like fingerprinting, I suppose, really. The rocks have characteristics that can be used to provenance to work out where they come from. So it might be the chemistry, but it could be the mineralogy, it could be the texture, it could be types of fossils. You know, all these things we use to help you or help us. The difficulty with the pebble is, unless it comes from the local geology, it's quite hard to know for definite where it's come from. I know that, you know, this pebble here, which I got up in Scotland, would have come from the Highlands somewhere. Which mountain? Hard to know. You might be able to pin it down to an area, but you wouldn't be able to say exactly where. So you could say, yes, there's an area of similar geology and similar rock types, but it would be quite hard to know. We can't, you know, there's not a little tag to say, oh yes, this definitely came from 5 miles down the road.
Right, yeah.
Just have a best guess, basically. It's a bit of fun, really, a bit of detective work, a bit of fun.
Right. Clive?
Hello there, Joe. Hi.
Great talk. Thank you.
Oh, thank you.
Your the iGeology app that you mentioned.
Yes.
Only seems to be available for Apple. Is that right?
Apple and Android. Yes, for both.
I was just looking just after you mentioned it. I was looking for Android, and it only seemed to show up an Apple version. You say there is an Android one.
There is an Android version, and the link is probably on our BGS webpage. If you Google iGeology and BG and on our website, bgs.ac.uk, /iGeology, you should, I think that's the address for the iGeology page. There should be a link for the Android version there, I think.
All right, lovely. Thank you.
Look, Joe, if you don't, get in touch with Peter. I'll have a look and see if I can find it.
Okay.
No problem. Okay, we got Patricia.
Go ahead.
Oh, hi. It's not so much about pebbles, but about where they come from. My parents lived down near Rottingdean on the south coast, so you've got a lot of chalk cliffs there. But what we always noticed was that there were layers of black, what looked like pebbles or rocks within the cliffs. So you'd have the white chalk, then you'd have this particular layer of black, and then you'd have white, and then you'd have these black pebbles apparently again, and then white again. And I was wondering, how on earth did that come about?
Well, that is the flint. So in the rock, so that is actually the flint layers, and you're absolutely right. You get horizons, and I think what's happened is that at certain times, a lot of these sea urchins have keeled over. So there's layers of these fossils, and I think that they have then the little spines from the sea urchin have then coalesced into silica, and that silica is then formed. And what happens is it will then migrate its way into little burrows in the sediments, and you'll often find it in funny shapes. You get all sorts of weird shapes like this, you know, and you often have holes in it, and it's peculiar. It's because it's colonized an existing void that was there, created by another animal. So, and you'll get those burrows maybe in a layer as well. So I think you've got a combination of things there, that you've got these burrows and the animals dying at the same time. But no, I've noticed the same thing. I mean, it's natural in geology to have layers because they represent a certain time period, and in that time period, during the Cretaceous, when virtually the whole of Europe was covered by sea, they wouldn't always be the same depth. And over time, it might be nearer to land or further away from land. And that would control what lived in the seabed. If it was too far away from land, there might be not a lot going on. A bit closer, there might be more life. So those sorts of factors make a difference as to what you actually see in the geology. But all we see is one cliff.
Yeah.
But the actual environment that rock formed in had changed over time. So yeah, it is flint in there, and yes, it's interesting. And my colleagues could probably talk more about this, about the geology, because they actually are the ones that do the geological maps. But it's fascinating. You're absolutely right. The thing I like about it in some places, you get them in just near Sheringham in Norfolk. There are things called paramudras. A paramudra is like a boulder-sized flint, and then they are amazing. But they're not just round; they're all sorts of weird and wonderful shapes. They're incredible. It's one of my favourite terms, paramudra. It's one of those words that's stuck in my head. But how on earth that formed? Crikey, must have been some big burrows.
Thank you, and thank you for the interesting talk as well.
No, my pleasure. My pleasure.
Thank you.
Anybody else? No? Right. Well, to go back to flints,
yes,
which have been mentioned. I'm not, if you go down south, you get these, you know, it's used as a building material, and
yes,
your typical flint has got this black inside, but it's covered in white material. What's that? I mean,
you're absolutely
because obviously the centre of the flint is very hard.
Exactly, you're absolutely right. I mean, here we go. Here's a classic flint, and it's got that white crust on it. And this white crust basically is the same stuff. It's just developed on the surface. And I think what's happened is this is in response to the pebble formation, because when it's being rounded, it's continually being bashed. And I think what's happened is the surface of the flint has just got fractured, and it's just so it's basically created, because sometimes it can feel a bit powdery. But we know that if we break it open, we get this very black looking, I haven't got a piece of dark flint here. But the other thing as well, it has quite a strange sort of semi-conchoidal way it breaks as well. And that's quite characteristic of flints. But it almost looks like glass. And it's made of the same stuff as glass. I mean, it's made of silica, and glass is mostly silica. So it has very similar sort of properties in that sense. But yeah, but the thing that confuses people about flint is it can have all sorts of different appearances. It can be any color. It seems to be, it's like it's disguising itself, but ultimately you break them. I mean, brown ones, all sorts of different colors. You break it and it will still be the same inside. Yeah, it's interesting, but the thing that amazes me is that it has a biological origin. It's a biogenic material, and that's amazing to think it comes from it's essentially fossil silica.
Yeah. Yeah.
There we go.
Any other questions?
I was just going to ask, I mean, it always amazes me on these television programs when they say, oh, we saw a meteorite, and then they show these tiny little meteorites. I mean, for goodness sake, they look just like pebbles to me, you know. First of all, really, how do people realise that they're meteorites? And have you come across many meteorites on your beaches when you look at them?
I personally, unfortunately, haven't found a meteorite. That would be amazing. I think a lot of times meteorite finds are tracked because they basically track meteorites coming in, and we get so many hundreds of thousands of tons of space debris that doesn't make its way through the upper atmosphere. It's all burnt up, and the reason we only get tiny fragments on the ground is because most of it is gone. It's been burnt up on entry into the atmosphere. But people specialize in this, and they will then track down this meteorite and then look for the fragments. And some of the best places to find meteorites are in deserts and also in tundra, areas where there's very little vegetation and it's very flat. And it's very easy to spot something black.
Oh, right.
You'll often see that. One thing that, I mean, it's not quite related, but you do get a really interesting desert formation called fulgurite, which is essentially melted sand caused by lightning strikes. So lightning has struck the desert, and what it's done, it's basically melted and fused as it's gone into the sand, and you get this long, thin, weirdly shaped thing of silica. It's the most amazing thing. I've never found one of those either, but that is incredible to these things get formed. But a meteorite would be amazing. Unfortunately, I do get asked this question about meteorites quite often, and mostly the black thing turns out to be a piece of glassy slag from an industrial process or some other artificial material, unfortunately, or even a bit of flint maybe. It's a shame because, you know, it'd be lovely to find a piece of meteorite, and we do get them in the UK. We do get meteorites, very rare, but they do occur. Some of them don't look very interesting. Some of them look a bit more like a brick. You know, they have a very earthy brick-like appearance. Others have a very metallic sort of metal surface. Others are called stony meteorites, and they are quite boring to look at. I think it's the metal ones that people want, really.
Thank you.
No problem. Okay.
Anybody else?
Can I just say a quick something I found out? I've had an iPhone in various forms for about 10 years. And now, only 3 or 4 weeks ago, did I find out it has a fantastic app called Magnifier hidden beside it. Can you see that?
Oh, you can, yes. Yeah.
The magnification on this is phenomenal.
Oh, excellent.
It's absolutely phenomenal. And as most children these days seem to have an iPhone or Android phone, I do recommend it. You just type in, when you go on to search for at the beginning of the program, just look for Magnifier, and that is absolutely brilliant.
I should look for that. Thank you for that, Stephen. I've actually got for my phone, I've got a clip-on lens that goes over my camera. So it's a bit like having my hand lens on my camera. But the reason I've done it is so I can take photos through my phone of rocks. So I shall look for that, definitely. Thank you.
Yeah.
Cool. Okay, everyone. Well, I suppose my last message really should be look out for my book. And thank you very much. I am more than happy to answer any questions if you suddenly pops into your mind after the end of the talk. Maybe you could send them via Peter, or maybe seek out the Facebook group Pebble Spotters, and you could ask it there. And if you have any questions about pebbles, post a picture on there. We're more than happy to have a go. I'll welcome you in and see if we can help identify the pebble.
Right.
This looks like Stephen. Let's have a look.
Yeah.
Let's see what I can see. looks a bit like almost looks like a donut. It's a strange looking. It's difficult to tell because it's quite small. It's a very fine grained, like a limestone, siltstone.
It's got quartz in there somewhere. Look at it.
It's got veins in it. You can see. I can see a vein running. This is probably partly explains the shape of it. That vein through the center. But where did you get this from, Stephen?
I didn't put a piece of paper inside the polythene bag.
You put a piece of paper in.
I didn't put a piece of paper inside the polythene bag.
I see. So you can't remember. I see what you're saying.
I can't remember where it came from. No.
Okay, no worries. Okay.
Just a unique shape and just fascinating.
Well, yeah, exactly. I mean, you don't need to know. If you like it for what it is, that's fine as well. Thank you.
Okay, thank you, everybody. And thank you, Clive. That was excellent. I think we've all enjoyed that talk. So if we could all...
Thank you very much. I enjoyed it. I think.
And thank you again for standing in at such short notice. And yes, if anybody has questions and they want to direct them through me, I'm happy to pass them on to Clive, or you can contact him directly, whatever you want.